Good morning, everybody on Zoom. Good morning, everybody in the lecture hall, people from the future. Let's start today with the end of this lecture on cloud storage. And then we'll continue with distributed file systems and HDFS, Hadoop, for those that might have heard about it. I'll start with a question that I would like to ask everybody to make sure that you followed last week. So here's the question. Which one of these cannot be stored as an object in S3? Is it the first episode of Star Trek Discovery? Is it the 300 petabyte dataset containing proton collisions released by CERN, the static pages of our websites, or an archived backup of your 2 terabytes hard disk? Oh, that's fine. Yeah, it doesn't really matter. Yeah. This, right? That's what you meant. All right. Okay, so the votes are coming in. Start looking at what you say. Yes, the 300 petabyte data set containing proton collisions released by CERN. Can anybody tell us why? On Zoom too, you can tell us. Nobody in the room, maybe on Zoom? Does anybody know why? Nobody in the chat, then we'll tell you, but I'm pretty sure many of you know because there's a majority. Well, it's limited to 5 terabytes, right? One object cannot be more than 5 terabytes. So there is this cap, this upper limit on the size of the objects. It's that simple. So what do? You just split it into multiple objects, and we'll actually come back to this many times in this lecture. So let me come back here now. Okay. So where were we? We started with storage. That's the bottom of the stack. We started with Amazon S3, which means Simple Storage Service, S3. And this is a service in the clouds that anybody can register to with an AWS account. And then you can create buckets, you can create objects, you can upload them. There is this hard limit of 5 terabytes per object. There is a soft limit of 100 buckets per person that can be extended if you ask. I told you about all these contracts with the lawyers with 999.99999. So these are all the guarantees that you get in terms of durability. You don't lose so many objects, 1 in 100 billion, I think, over a year. Also the response time, the latency, and so on and so on and so on, right? Okay, so I also told you about the CAP theorem, right? That you cannot have all three of the vertices of a triangle, right? So this is consistency, availability, and partition tolerance. The idea is simply that when you have a partition, a network partition, 3 things can happen. The first thing is that you choose to be available, but you might not be consistent across locations. The second is you're consistent across locations, but you might be temporarily unavailable during the partition. And the third one is that everything breaks and the whole system is just down and beyond repair. So this is what it means. You drop either C or A or P. And there are companies now, a lot of them, because it seems that everybody is following now, who claim all 3, so C, A, and P, but they're actually a bit distorting the meaning of the CAP theorem, because the CAP theorem is not about consistency and availability when things are okay. It's really about choosing between consistency and availability when there is a catastrophe and a network partition. And so the companies that claim all three, they basically play with the fact that network partitions are actually rare. And so the system feels available and consistent at all times. Okay, but don't fall into the marketing trap. So now I would like to show you something that you didn't know you knew, which is called the REST API. I'm saying you didn't know you knew because you actually, I'm pretty sure you use it every day. You know how it works, the web, right? You type some address in a browser and then the page magically appears. Well, this is actually kind of a REST API or a human REST API. So a REST API is just the computerized version of the web. It means that instead of a human typing the address in the browser, it's a computer sending the request. And so this can be used actually to automate communication over the web. This is called the REST API. This is nothing else that's what you do in your browser, but computer to computer. So why is it useful? Well, it's useful because whenever you have a piece of technology, as we will see them in the lecture, S3, HDFS, database systems, and so on, you will have several ways to access it. One way, the oldest one, is via a proprietary interface, meaning that whoever makes the software or the database gives you what is called the pilot that you install on your machine. You don't know what's inside. It's just something that magically makes a printer or a scanner or a database work. So this can be, this is proprietary. And when you have a driver, you can access it, access the database from the terminal, from programming languages like Java, from notebooks, and so on and so on. In the case of PostgreSQL, that's actually what happens. REST is an improvement of that because it's more open. So it's like, it's exactly like, sorry, not a pilot, that's the French word, I don't know why I said that, the driver. You install a driver for a printer or a scanner. And so it's a fancy version of a driver. But it's more open because the interface and communication between the Jupyter notebook and the storage system, or between the programming language Java and the storage system, happens via HTTP, which is the web protocol, the same protocol as the web. This is called the REST principle. It was a PhD thesis by a student, and it comes down to using HTTP the correct way, right? Okay, so if just a few words that the web, not to be confused with the internet, was invented here in Switzerland, in Geneva at CERN in 1989, 1990, by this person right here, so Tim Berners-Lee, who you might have heard of. And it was a huge revolution, as you know, because now we are doing everything via the web. Even the smartphones connect via the apps, many of them through the web. And originally, it was just about displaying pages with images and so on. And then you had links, which is called the hypertext link, that when you click on it, you land on another page. Today, it sounds trivial because we do it every day. Back then, that was really a revolution to have something like that on the worldwide scale. So let me tell you a few words, even though that might be a bit familiar to you because you've seen these HTTP:// things in the browser. It's exactly the same when computers talk with computers. The idea is that these things here that start with HTTP, they have a name in REST. They're called the resource. A web page is a resource. An image is a resource. A video is a resource. Everything that can be identified with this is a resource. So there is a name for this thing here, HTTP blah, blah, blah. It's called the URI, Universal Resource Identifier, right? That's what it's called. And just so you know what it's made of, because you might be interested, HTTP is the scheme. There's actually others like mail2, FTP, and so on and so on. There's others, but HTTP is one of them. Then you have what's called an authority. This is the domain. Maybe some of you, who has a domain here? Some of you, right? So you can buy them and then belong to you. This is called an authority. Example.com belongs to nobody. That's the one you can use in lectures like the 555 in Hollywood movies for phone numbers. Then we have a path. That is, you see that in the address bar in the browsers that lead you to a specific directory and page. And then you have the question mark. This is used when you have formulas, forms, online forms. You click on them, you fill in the text boxes, and then it can be passed like this as parameters, right? So this is a way to tweak a web page with extra extra parameters, right? And then this shark here, you don't always see it. It's called the fragments. This is how probably you see it on Wikipedia, right? It's already happened that you click on a Wikipedia link, but it directly shows you a specific section of the page. It doesn't put it at the beginning. It directly jumps at a specific section. This is what the sharp does. It directly scrolls down to the right place. So now you know this is a URI. This is what there is in a URI. And this is what we humans use in order to look at web pages. And this is what computers use as well to talk with each other. For whom is that clear? Don't see a lot of raised hands. Who already saw these things in the browser? Everybody, right? Okay, great. So I'm just saying that the computers do the same. They also type this in some virtual address bar, so to say, and then they get something back, right? And in fact, in the case of S3, and like actually many databases, there are also URIs that are used to identify buckets and to identify objects. So every bucket has a URI and every object has a URI, just like every page, every image, every video, but objects and buckets also have their URI. And so you can use these URIs with the computer programmatically in order to do things with the buckets and the objects, to do things. To do is a verb. And this is what we have in REST and in HTTP, it's verbs. Verbs are called methods. The verb says what you want to do with these resources. So there are several verbs like get, put, delete, post, and many others, right? So this you probably don't know because the browser is hiding it from you. But actually, it's very likely that behind the scenes, there's a lot of get and post. This is what the browser, when you navigate web pages, is typically doing. Get is when you just want to see a web page or an image. Post is when you really send information over to the server, like you register for a website or something, right? So the web, HTTP, REST, so the same thing. It's very simple. Every time you communicate with a website or a server or a protocol or whatever, you need two things. You need a resource, a URI, a resource, and a verb. So you need to say what you want to do and on what you want to do it. That's it. It's that simple. Every single request on the web is made of a verb and of a resource, a URI. For whom is that clear now? Okay, very good. So it's really that simple. I'm not going too much into the details, especially less because you're not computer scientists, but basically this is it. So what actually is going on below the scene, whenever you have computers talking with each other or your browser talking with a server, you have the method, the URI, and then plenty of extra information that gets sent along with it. Like if you upload something to S3, probably you will put here the image or the object you want to upload. And then this is the response with a status code. Who knows what a status code is? Okay. Whoever saw a 404? Everybody, right? This is a status code. 404 is one of the many status codes you can receive. 404 is page not found, right? But there's many others. So this is called the status code. This is what you get back. And then the body will be the image or the HTML page if you are a human. But if you are a computer communicating with S3, that's not going to be an image or anything. It's just going to be the object you have stored in S3, right? Okay, so it's that simple. Oh, that is too scary. That's the computers talking with computers. You can just ignore that. Okay, so now to the methods. What do they do? Well, if you say get a URI, it doesn't change anything. It's not doing anything. All it's doing is requesting a copy of the resource, some representation of the resource, right? So if you get an object, you just receive the object. If you get an HTML web page, you just receive it on your computer. If you get an image, you just receive the image on your computer. That's what get does. If it doesn't do that, or if it changes anything on the server, this is not good, then it means that whoever implemented that didn't do it right. Normally, it's not supposed to do anything. A side effect is a synonym for a change, when you change something. For example, when you upload an object to S3, this is a side effect, because after you've done that, then there is a new object on S3, right? So you change something. Get cannot change anything. It's just peeking, looking at something, and not like quantum physics, like classical physics. You just look at something without changing it. Okay, this is get. Put is the opposite of get, right? So you can put something on S3 or wherever, and then you can get it, right? And when you put something, it's exactly the same URI. You say put this image at that URI, which is, for example, some object URI. And then you do get with the same URI, you're supposed to get exactly the same object back, right? So you put it and you get it back. Now you might wonder, does that mean you can do put on ETH's homepage or whatever? Technically, yes. In practice, it will not work because obviously not anybody can do that, right? You need to be authenticated and, you know, so it will just not work on the websites that you don't control. But generally, the protocol of the web allows you to do this. Then there is delete. That is also something you cannot do, like you cannot say delete google.com, that doesn't work. But this is part of the protocol. In the case of S3, you can use delete to delete an object. This is a side effect. It changes something because then when you do get on an object you've just deleted, it's gone, right? And you get what status code? You know that? What status code do you get if you just deleted an object and try to get it? 404, exactly, the same one, 404, not found. Okay, very good, so you're following. And post is like, I don't know how to call it, it's, if none of the other methods is appropriate, then post is. Post is the more generic one. You can basically do anything with that. It's typically used when you want to create new objects in a bucket, because when you want to create a new object, you don't know its URI yet, right? So this is why you have no other choice than to go into the bucket using the bucket URI and then do a post in order to say, please create a new object for me and give me the URI of that new object. And then you can use that URI to change it, right? So this is pretty much how it works. You can put, delete, get objects and buckets through their URI. Get, when you do get bucket, it's actually more something like listing all of the names of the objects in that bucket. This is what you would say if you do get bucket. All right. So yeah, that's the REST API. That's what it does. All clear? Any questions on the REST API? Yes, we have the Cube microphone over there. Wow, a single hop.
Don, yeah. Can you just clarify what's the difference between put and post?
Put and post,
yeah,
right? Mm-hmm. Put is the opposite of get. It's in order to upload something to a specific place on the web, but you know exactly where, and in such a way that when you do get on the same URI, you will get it back, right? So if you say put an image at www.example.com/image.png, and you basically put it with the image, and after that, you say get www.example.com/image.png, then you receive it back. This is what put does. Post is for anything else when, for whatever you want to do, get is not appropriate, put is not appropriate, delete is not appropriate. When is put not appropriate? Well, it's not appropriate if you don't know yet where to put it, right? Put only works if you know exactly what URI you want to put it in. But in many cases, in S3, that's, for example, so let me give you an example of put in S3. Put is when there is already an object somewhere, you already know the URI of that object, and you want to replace it with something else. Then you use put with the same URI, and you're going to replace the object. But you cannot use put if you want to create a new object that doesn't exist yet. So that name doesn't exist yet, because then you don't have the URI. So you just do post, and then it's going to create some ID for you, right? This is especially used for calendars. For example, if you want to create a new calendar entry somewhere, you don't know exactly what the URI is going to be, so you use post. And then you would use put subsequently in order to replace or change the calendar entry, right? Now, to be very clear, this here, this get, put, post, and so on, so this HTTP protocol is generic. It's worldwide. It's a world standard applicable to anything, web pages, database systems, calendars, anything basically works. So what I'm telling you that get, put, delete, post do, these are prescriptions or recommendations. This is if you design a new service or a new website or a new database system, you are strongly encouraged to use these requests in the way that I'm showing here. But nobody will complain if you don't, except maybe your users, right? So somebody could absolutely do other things when you say get pod and not respect these rules. But normally, if you want to design a good system, you really have to make sure that get is really just getting a resource, that put is just the opposite of get, getting it back. Delete is really in such a way that when you do get after that, it's not there anymore with a 404. And post is really, it's for anything else, basically. For anything that put doesn't make sense, delete doesn't make sense, get doesn't make sense, then you use post, right? Now, this is the designer's perspective. In the case of the user perspective, you just need to look at the documentation. So S3 has a documentation on Amazon's website. And on that documentation, they will tell you exactly what each one of the methods does with all the explanations, the specific cases, the error codes, and so on, right? So when you have a REST API for a system, you also very often have a documentation page that details all the resource URIs you have, all the methods that are available, and what they do. Does it help? All right. Okay. Now, oh, wow. Okay. So now let's go away from the REST API. I think I've told you enough about it. And now let me tell you about S3 being a file system or not. Because what I told you about S3 is that it's made of buckets and object IDs. That's all I told you. It's flat, right? You just have a bucket ID and an object ID to identify an object. However, when people use S3, they will typically have these slashes in the URIs of REST or in the object IDs, right? So that sounds like a file system, right? If you have slashes, this sounds like directories, right? Like you have on your laptop. So this creates a structure and a hierarchy, a directory hierarchy for your objects. But here's the thing, this is fake. That hierarchy doesn't actually exist because technically to S3, the slashes are just a character like any other. So if you use the slashes, technically this is an object ID, this is an object ID, this is an object ID, this is an object ID. But you as a human might interpret the slashes are creating a hierarchy, right? It's intuitive as a human. So for this reason, even though internally the slashes don't mean anything to S3, when you actually use the fancy interface and connect to Amazon's website and then go to the navigator, to the viewer of your S3 buckets, it will actually show these as directories. So you can click on food and then you go inside, there is fruits and vegetables, then you click on fruits, then you see orange and strawberry and so on. But this is all fake. This is not actually happening inside S3. This is only a presentation thing, a display thing to the user, right? So it's very important to understand that S3 is really object storage, providing as a service in the cloud, and the slashes are just conveniently displayed as if there were directories, but this is fake. For whom is that clear? Okay. Something nice that you can do with S3, and it's actually quite popular to do that, is to host websites because it's super cheap. Super cheap. The costs of that are so minimal that it's much cheaper than setting up your own computer and web server. But it only works for what is called a static website. A static website just means that there is no dynamic code executed in there, right? An example of static sites is, so this one is a static site. It's just displaying whatever information there is. It's just a plain HTML page. An example of non-static site is a search engine, right? Because a search engine, you type something, you interact, and the content is generated dynamically, right? The search results, it's dynamic. So for that, you cannot use S3. But if these are pages that are static, that are always the same to anybody who tries to view the page with a get, then S3 is exactly what you need, right? So it's going to create some URL with the bucket name .s3 website EU central one if you put it in frankfurt.amazonaws.com. And what people typically do is that they also buy a domain and then they tie that domain to this. So then when you type your domain, in that case, jsonic.org or jsonic.com, it's actually going to automatically get from S3 the contents, right? So super cheap, It's not the only ones. We see there's also Azure Blob Storage. So almost every cloud provider has something equivalent. It's a super cheap way of creating static websites. It can also have images, videos, and so on, as long as this is not dynamic, as long as this is always the same to everybody who views the website, no interaction. Okay. Another use case is the hosting of data sets. You can host data sets in S3, putting every how can I say, there are so many words for that, every part of your data set as one file. So this is typically something you can have. Here, this is the fancy viewer. If you connect to Amazon AWS, it will show you this. The slashes will be treated in such a way that it feels like a directory structure. As I said, it's fake. And in that case, I basically navigated to a few directories within that. And then this is what I see. You can see the sizes here. This is very typical. I have created these objects of each a size of 500 megabytes roughly, and I have many of them. There's many ways you can call these objects. First, you could call them files if you want, even though I said it's fake. It's not a file system, but you could consider that these are files because this is how it feels when you look at them. You could call them chunks, parts, shards, splits. There are many words for that. This is basically the idea that when you have a gigantic data set, you typically split it into smaller parts, right? So in that case, the data set is, let me try to compute, 1, 2, 3, 4, 5, 6, 7. It's probably 7 or 8 gigabytes that you see, 7 or 8 gigabytes. But I cut it into 500 megabyte chunks, right? And each one of these parts is one object in S3, right? For whom is that clear? Okay, now there is one thing that might confuse you is that what is this XAA, what there is inside and so on. This we will see in the next few weeks. It could be XML, it could be JSON, it could be CSV, it could be text. You know, these are just data sets, but there are so many formats that you can have your data sets in that this is something we are leaving for probably in 2 weeks, next week or the week after that, right? So this is why now I just put things that don't mean much, but we will see in a few weeks what there is inside these objects, right? For now, we are just looking from outside at the storage system. All right, who is following? All right, very good. Don't hesitate to ask questions. I know also it's the very early morning. It's not even 9 a.m. yet, I'm trying to not push too much. All right. This we will come back many times. This is one way to store your data sets is S3. Blob storage is an equivalent hosted by Microsoft, by Azure. Google Cloud Storage has also something similar. And we will then, in the second hour today, look at HDFS, which is yet another place that you can store these data sets. But this is very, very typical that you have a directory, a fake directory, of course, in that case, containing many files. Fake also, these are not actual files, this is all fake, so objects that have a similar size, but lots of them. Dozens of them, hundreds of them, even thousands of them in the same directory, fake directory. And this is how a data set typically looks like. Okay. Now a few high-level things. So you can choose how much you want to pay depending on how you want to use that storage. If you want to use S3 in order to query your data set in real time, or in order to host a website, you need the standard version, the one that gives you reasonable response times, right? Typically a few hundred milliseconds, which is totally fine for a website. However, there are people that use this storage service in a different way. They are not interested in a website or real-time data sets. Some people use it as backups. They just want to keep a copy of their files. A company, for example, want to have a copy of all their files there, but they don't care that it takes 300 milliseconds to get them. They don't care about that. It's okay if it takes a few hours to get them, right? And so this is called Glacier, Amazon Glacier, which is much cheaper than the standard version. If you don't mind that when you request an object, you have to wait for a couple of hours until you get it. right? If you don't mind, then this is going to be cheaper. And this is the reason for that is that typically this is put on tape. You know these tapes that that are magnetic and so on and so on. So they still exist today, and even ETH has some of them. So the backups of your student directories are actually on tapes somewhere. And typically these places where you have the tapes now, they are all automated with robots, you know, that just fetch the tapes and bring them to you and so on and so on. But it can take hours until you actually get the data from one of these tapes. Right? It's basically the counterpart of being cheaper. Okay. Now, so this is S3. I told you about S3. It's a cloud service. You don't need to install anything. It's just something you have in the cloud. You can create buckets, upload objects. If you have computer programs, you can use the REST API to interact with them. You can use it for static websites. You can use it for storing your data sets. You can use it for backups. There is another use that I haven't told you about yet. It's by Netflix, Disney+, you know, all of these services. They actually use S3. And what they store in there are fragments of movies or fragments of series, right? And so you might not know it, but maybe you can see it in somewhere on your laptop where it connects to. But when you're actually watching a movie or even on YouTube or whatever platform, it is actually sending GET requests to S3 or blob storage or whatever to just get a few seconds of the series. And every couple of seconds, it fetches the next 10 seconds. This is how it's able to switch between resolutions, right? Low resolution, high resolution, depending on the connection, because every couple of seconds, it's just fetching the next 10 seconds of your movie, right? So you might not have known it, but this is actually on S3. Okay. Or blob storage, you know, or Google Cloud. So typically, in fact, they use all. So a company that like Netflix is typically a customer of many different cloud providers, and they spread it all over the clouds, right? So this is if one of them is down or there's anything, then there is another one to use, right? So typically it comes from everywhere. Okay. So now, very quickly, and again, I'm not going to spend as much time as on S3. I just want to show you Azure Blob Storage, which is the Microsoft version of S3. I have to give you a warning, is that blob storage, even though it's the counterpart of S3, is a bit more complex and advanced than S3, because it's kind of hybrid between S3 and HDFS that we will see in a moment. So that's the reason why I started with S3, because it's simple enough. But let's go in there and let's see why what you learned about S3 is still going to be useful here. The first thing that you will notice, if you look at Azure Blob Storage, is first that it's the same idea that you have something like a bucket and something like an object, and you can upload files and you can get them back, right? It's the same idea. But you will notice that the words are different. It's like going to Vallis and hearing people say embry and embruf, right? So it's exactly the same idea. And then you just need to learn the words, right? So in the case of Azure, they don't use buckets and objects. They use accounts, containers, and blobs, right? So a blob is like an object. And the account, which is your login, your email address, or whatever, the name of your account, plus a container that would be a bucket, but within your account, right? And then a blob, right? So the difference why there is no account in S3 is that a bucket name is unique worldwide. You cannot have two people who have the same bucket name. But in Azure, it's totally fine to have the same container name because you anyway have the account to disambiguate, right? So just different, but very similar. In the object API of S3, if you have a large object, like a few gigabytes, it might not be easy to upload it in just one time. Like 1 gigabyte in just one time, you probably tried it over the internet, it tends to break, there is a network interruption and so on. So what you do is that you have the possibility to upload it in smaller parts, right? So you communicate via the REST API with S3 saying, okay, this is the first 100 megabytes, these are the next 100 megabytes and so on. And then when you're done, you'll say, okay, now just put them together, this is my object, right? So this is done in parts. In the case of Azure, I told you it's a bit more complicated. There is the notion of block-based object API. I'm not going to tell you anything because we're going to cover it in HDFS. So this is why I'm jumping very quickly over that now. Happens is that you can only add, you can extend existing objects by adding more at the end. This is useful for logging. If you just have a journal that takes notes of what's going on, then you just append at the end, right? Every time there is something new. These are called append blobs. And then you have the page blobs that are basically used as memory behind virtual machines on Azure, right? So you see that it's slightly more complex, but this is just a detail of how you interact with the object API. It has, depending if you use blocks, append, or page, you might have different size limits. So you see in the case of S3, it's 5 terabytes. In the case of Azure, you see that if you use these append blobs, then it's less than 5 terabytes. You're limited to 195. If you have blocks, it can be much larger, 190 terabytes in that case. Why that is, I'm leaving for the next lecture because I'm gonna tell you why. You can actually fit more if you use blocks, right? So this I'm just keeping for later, come back to it. And the page is, in that case, 8 terabytes, so similar, right? If you don't know which one to use for blob storage, blocks are the ones that you should go to, right? But again, everything will become absolutely clear after we have covered HDFS. Then you will know what a block is and how that actually works. So unlike S3, which is kind of not transparent, we have no idea how S3 is implemented because there is no paper, there is no documentation. So we know how it feels from outside, but we don't have details. However, in the case of blob storage, we have details because there is an academic paper and there are explanations. So maybe Amazon does it in a similar way, maybe not. I have no idea. They don't tell us. But in the case of Azure Blob Storage, we know. And the way it works is that they have, you remember these racks when we have the computers that we pilot on top of each other, that gives us racks. And then in the data centers, we have plenty of racks in the same rooms. And so what Azure does is that they take 10 or 20 of these racks. So we are really speaking about hundreds of computers here, 10 or 20 of these towers, and 18 on each of them. So this is like roughly 400 computers in there, 300 nodes. If you look at the hard drive of these nodes and put them all together, all the hard drives combined gives you roughly 30 petabytes of storage. This is called the storage stamp. It's one room in a data center where you have all of these racks. And Azure has this many, many, many times all over the world. So they have many, many of these storage stamps, many of these rooms filled with computers like that. And they try to keep the storage capacity with a margin. So they try to fill it only 70, 80% with 20% of free space, just as a buffer. And if it starts going up, and approaching the 100%, they are just going to open new data center rooms and new storage stamps, and then they're going to redistribute spread the data over all of their places, right? To bring it back down to 80%, right? So they have this little buffer. You know how it is when your hard drive is full, right? To whom it already happens that the hard drive was full and you get this error. Okay, so you know, so this is why they keep it to 80%, because we don't want that to happen. Okay. So then I'm gonna save you the details on that. These are the slides that I show for a big data for computer science students. So maybe very quickly, and it's really no big deal if that doesn't make much sense. But the idea is that this is the internal architecture of the whole system, is that we have multiple layers in the way the system is built. It's like when you build a house, you have the plumbing, the electricity, and so on, right? So this is a bit the same here. So you have a layer that's called streaming, and it's the same streaming as for, you know, Netflix, HBO, and so on. It's exactly the same idea. This is where you get the bytes, the bits from the objects. Then there is a partition layer. And the partition layer is when you move over objects between storage stamps. For example, if this is full, you are above 80%, then you are going to be moving the objects across data centers or over rooms via at that level. And then the front end is where the clients or the customers are actually connecting in order to use the system. Okay, but again, I didn't want to bore you because this is really getting a bit technical and more than what you actually need to understand. So you can even forget these two slides if you want. Okay, but now I told you they have these rooms, these storage stamps all over the world, in all continents. And there are reasons for that. There are several reasons actually. The first reason is that if you have customers all over the world, you want to have data centers or computers next to them. Because if you have computers here in Switzerland, but you have customers in the US, in Canada, in Latin America, in Asia, in Africa, this is far away. So the time it will take for the web pages to load is going to be too high, basically. So what you do is that you have data centers all over the world, and the people will just automatically connect to the nearest data center, and then that reduces latency. So this is how the pages can load a bit faster. We are basically limited by the speed of light, right? The light has a limited speed, and when it goes around the Earth, then that slows things down. And to add to it, it's not even at the speed of light. The internet is even slower than that. Okay, and the second one is the resilience to natural catastrophes. Because if you have an earthquake or a tsunami or something that destroys all of your infrastructure, so first, it's absolutely terrible for the people, the casualties and so on, it's terrible enough. But in data centers, you also store critical structures, right? Even including the structures that are actually used by the emergency services to locate people. You need to have the systems up and running, right? And also for all the infrastructure for society to work, right? So you need to be resilient to natural catastrophes. And this is why you typically have all of this distribution all across the world, and you replicate your data across multiple locations so that if one of the data centers is gone, then you still have the data at other places. And in fact, these things happen. It doesn't even need to be an earthquake. It can be just a fire. There was an example a few years ago in France, in Eastern France, that a data center burned, and they had huge problems because they hadn't replicated the data to other places, or at least their customers hadn't, and then they actually lost data. So you can imagine the damage that it does when companies lose all of their data. A company can just basically go bankrupt because of things like that. So you really need to be careful with this, right? So these are the main two reasons why it's spread all across the world. But I have to add one more thing to this before we go to the break. It is that you might not be able to distribute it all across the world for legal reasons. And here I'm thinking of data protection laws, like the one that starts in September in Switzerland, or GDPR in the EU. You might not be allowed to actually have a copy of your data at other places. So this is also something that you need to consider when you have data centers, right? You need to be careful about these things. So for example, if you want to have GDPR in the EU, you can still have in Frankfurt, in Paris, you know, at all the places across the EU, and then you're basically respecting the law while distributing your data all over the place. In Switzerland, it's a bit smaller, right? You can still maybe get it, I don't know, in St. Gallen, in the Geneva, in Zurich, like you can still try to replicate at many places, maybe just a bit more challenging because the area is a bit smaller, right? But these are things that shouldn't be forgotten, right? Because data protection is really becoming increasingly important, and of course the companies have to respect these prescriptions of the lawmaker. Okay. Then a few last words just to contrast, because now I showed you Amazon and Azure. Just high-level words on the mindset of how it feels to be using Amazon or Azure. Amazon likes to have hundreds of services. Each one of their services does one thing, and it does it well. S3 is a service, but there's many others. There is a service that provides you with relational databases, just like PostgreSQL. There is a service that provides you with virtual machines, like Linux. You create a new virtual machine, you connect to it, and you have Linux. There are services that give you domain names. There are services that host the DNS entries for your domains. There are services that host key value stores, which we don't cover in big data for engineers, but they exist, and so on and so on and so on. So it's made of many services. You can connect basically to the console, and then you see the list of services, and you pick the one that you want. In Azure, of course, they also have many services. But the mindset is a bit different. They have services that are a bit more polyvalent in the sense that they can do multiple things at the same time, right? So an example of that is Azure Cosmos DB, which handles trees, tables, graphs, key values, and so on, right? In Amazon, it would be one service for trees, one service for tables, one service for graphs, and so on, right? So this is just a high-level comments. What are the takeaway messages from this cloud storage lecture, that's the last slide now? We simplified the model. We went from a file hierarchy to just key values. So bucket plus objects ID, that's the key. And the value would be the actual content of the objects, of the image, of the video, or whatever. Buy cheap hardware. Now you know that in a data center, we just pile up these cheap computers on top of each other in racks, and then we fill the rooms with racks. And this is how we get data center, plenty of cheap hardware. And removing schemas, I don't know why I didn't remove that. It's just that I used to talk about that, but we'll see it in a few weeks. It's the idea that when you have a file system locally on your laptop, you typically have a lot of metadata. If you do ls in Linux or dir in Windows, then you see a list of files with metadata, right? With the owner of the file, the size of the file, and so on and so on. In the case of S3, it's actually more flexible than that because the properties that an object can have are flexible. It doesn't need to be the same properties for all objects. So this is what I meant with that. But I'll come back in the context of other resources to removing schemas. Okay, I think you deserved a break now, so we'll take 15 minutes. And right after the break, first I'll answer questions if there are any, and then we look into HDFS, the Hadoop distributed file system. So thank you very much, and see you at 16 past in 15 minutes.